Okay, so we have ourselves another type of problem very similar to what we did with arithmetic sequences. They're asking us to use the given information, a sub 2 equals -6, and a sub 7 equals -192, in order for us to find a sub 20, the 20th term. So the only issue, again, if we do have general terms, we have a sub n equals a sub 1 times common ratio to the n minus 1 power, or n minus first power. If we were to try to find a sub 20, the issue, I'll kind of plug in n equals 20. We can simplify a little bit, a sub 1 r to the 19th. We still have to know who is a sub 1 and who is r. So just by looking at our given information, we are not given that. And 2 and 7 are not close together. So what we'd have to do is set up a system of equations with our knowns using the general formula as well. So let's start off with this a sub 2. I'm going to plug in what happens when n equals 2 to our general formula. So we'll kind of circle that above here just in case you know what I'm referring to. Or box it. There we go. So this is going to leave us with a sub 2 equals a sub 1 r to the 2 minus 1. Just simplify it a little bit further, a sub 1 r to the first power. 2 minus 1 is 1. If you'd like to write it in, you don't have to. So let's do the same thing with our a sub 7. So a sub 7, that's what happens when n equals 7. So a sub 7, again, referring back to our general form, general term. A sub 7 equals a sub 1 r to the 7 minus 1. Clean it up just a little bit. A sub 7 equals a sub 1 r to the 6th power. Now, again, what I want to do is I actually do have these values for a sub 2 and a sub 7. So I'll just replace a sub 2 with -6, which gives me a sub 1 times r, and a sub 7 with -192, which gives me a sub 1 times r to the 6th. So this is our system of two equations. And our two variables. I know you're used to x and y, but our two variables happen to be a sub 1 and r, common ratio. So what I like to do, I notice that there's no adding or subtracting happening in these equations. I'm thinking substitution method would probably work better for this. So you can kind of decide what you'd like to work with. I will start off with the first equation. It looks a little less complicated, a little smaller numbers. And I can decide, do I want to solve for a sub 1 or would I like to solve for r? Doesn't really matter. Sometimes one way is slightly easier than the other, but in my experience, the more you do, the more you'll figure it out for yourself. But I'm going to solve it for r. So substitution method, I'm going to take this and I'm going to solve it for r. And if I solve for r, what am I doing is I'm actually dividing both sides by a sub 1. So if that is the case, that's going to leave us with r equals -6 over a sub 1. So now what we can do is plug this into the other equation. So if we plug this into the other equation, this will leave us with -192 equals a sub 1. And then now we're plugging in for r. So r again is -6 over a sub 1 all to the 6th power. So now it takes a little bit of calculator work. I do notice that I have a sub 1 already. I can use exponent laws to help me get this other part down. I have negative 6 to the 6th power, a sub 1 to the 6th power. So that's going to allow me to simplify a little bit. I have, so simplify this. You have a sub 1. We can reduce it out. So that's going to leave us with a sub 1 to the 5th in the denominator. Well, canceling. Now, negative 6 to the 6th power, we would definitely pull our calculators out. And we should get 46,656. And I'll get rid of the comma. 46,656 equals negative 192. And you'll notice, okay, we only have one variable left, that's a sub 1, but it's also taken to the 5th power. So we're going to take our time to look at how do we solve this type of equation. We have rational equation in a way. Let's take a multiplication on both sides by a sub 1 to the 5th, just to get rid of that fraction. I'm going to take this off to the side so you all see. Let's go this way. So on the left-hand side, I will end up with negative 192 times a sub 1 to the 5th. And on the right-hand side, you'll notice that we still have 46,656. 46,656. It's a lot of sixes, so keep track of that. Now what you could do for yourself, remember it's a sub 1 to the 5th. That's kind of our key issue here. You might want to isolate it by dividing both sides by negative 192. And sometimes, if we get lucky, we get a nice integer. But don't sweat it. If you don't get an integer, you get like a decimal. Keep it in fraction form. So let's see what we get with this one. I should have a sub 1 to the 5th. 46,656 divided by negative 192. We actually do get a nice integer, negative 243. So at this stage, you're saying, okay, I got to solve for a sub 1. Well, in order to solve for a sub 1, this would be having to undo that 5th power. It's a little bit of experience with solving powers equations. So we can take the root of each side. So this would lead me to use maybe taking the 5th root of each side. So that would leave me with a nice single a sub 1. And on the right-hand side, I do have a 5th root, and it's a negative number. But don't sweat it because you can use that. You just know that the number will be negative. But let's switch off to the TI so we can find that. Just in case we haven't done this in a while, so let's see what we can do. Again, if we want to take the 5th root, sometimes you have to press the root number first, which is 5. Press the math key. And then that's item number 5. If you scroll down, that's the X root. So that's indicating you're using the 5th root. So we can type in negative 243. And then if we do get a nice number, great. If we don't, we'll just use the exact value. But look at that. We got a nice number. That's negative 3. Okay. Let's move back and plug that in. That's really convenient. A sub 1 is negative 3. Wonderful. Now, I know we get really excited because we found a variable. We have to remember what we were trying to find in the first place. So let's go back. They want us to find a sub 20. Okay, so we can resubstitute into our particular a sub 20 format. I'll highlight that right here. I do have a sub 20 equals a sub 1 is -3. So I can do that, I can find that. However, I need to figure out what r is. And I need to be able to take that to the 19th power. So if you noticed, what we did earlier is we did have a system of equations where we found a sub 1 equaling -3. We did have the equation solved for r on this right-hand side over here, or it's the left-hand side if you're looking at it. So if we actually have, let's plug this in, r equaling -6 over a sub 1, and we just found that a sub 1 was equal to -3, we have a nice minor computation where we actually get r is equal to 2. So that's really, really good, because if you want to scroll back up and plug in 2 to our particular formula for r, we now have the exact value of the 20th term. It is now up to us to plug it into our calculator to get a nice value that we can actually read. So sometimes it may be big. We may have to use scientific notation, but let's see what the calculator gives us. Okay, so if I'm plugging this in, remember I have -3 times 2 taken to the 19th power. So press enter. And actually that number is not too big. It's not in scientific notation at all. It's in the millions. So all we'll do is just copy it over. So we'll go back to our screen so you can see my a sub 20 getting written down. I have actually -1,572,864. And again, if I'm using the commas to separate those periods of the numbers, that will help me. But now we do have our final answer. So that's what we have to enter in. So I hope this helps. It's a little spin on solving systems of equations. I know usually we're used to using elimination, but in this case, with a lot of the products, using substitution is definitely helpful. We can use that, practice a few homework problems, and I will see you in the next example.